Bismillahirrahmanirrahim. I am Dr. Amir Badsha, lecturer in Department of Chemistry, Cohort, University of Science and Technology. Today, the topic of our lecture is reaction of benzene, diazo-coupling reaction, and diazotization. This is lecture number 21 from the course Organic Chemistry 2nd, having quote Chem 322. The outline of our lecture will be included: introduction, diazotization reaction and Sandmeyer reaction, Shaman reaction and diazo-coupling reaction, and the coupling of the diazonium ion with the phenol in aniline, and at the end we will mention some references. Before diazo-coupling reaction, we should know about the diazotization reaction. When a primary amines, not secondary and tertiary, but a primary amine react with sodium nitrite in HCl, it produces a salt which is called diazonium salt. A reaction in which primary amine react with sodium nitrite and HCl to form a diazonium salt, such reaction is called diazotization reaction. For example, here it has been shown that nitrogen is bonded with one alkyl group, so it is a primary amine. When this primary amine react with sodium nitrite in the presence of HCl, it forms a salt. This alkyl diazonium chloride, this salt formation reaction is called diazotization reaction. Mechanistically, how this reaction has been occurred: actually, first sodium nitrite react with HCl. By reaction with HCl, it is converted into nitrosonium ion. The nitrosonium ion is a resonance stabilized species. These electrons are shifted here. So sometimes this positive charge is present in oxygen and sometimes this positive charge present on nitrogen. But mostly it is present on nitrogen because it is less electronegative compared to oxygen. This nitrosonium ion is then attacked by the primary amine. These electrons are shifted toward a nitrogen and we can get this species. Then from the resulting ammonium ion, this is a type of nitrosonium ion or ammonium nitrosoammonium ion, then it is deprotonated, and after the deprotonation we get nitrosoamine. And then in nitrosoamine, oxygen is protonated and we get nitrosonium ion, where oxygen is bonded with hydrogen and has a positive charge. And then further this hydrogen is abstracted and a double bond is formed between a nitrogen and another, these two nitrogen, and this double bond is shifted here. Further again this oxygen is protonated in order to make it an excellent living group. After the formation of this species, then this oxygen is removed or go out or lives in the form of water and we get this diazonium cation. So this is the overall mechanism of the reaction, and in simple, a primary amine is treated with sodium nitrite and HCl and form a diazonium salt. Such reaction is called diazotization reaction. Diazotization reactions, especially it is limited only to aromatic amines. For saturated primary amine, this diazonium salt is very unstable. If we try to make the diazonium salt of saturated compound. This is saturated part. So we will get diazonium salt, but this diazonium salt is very unstable. At the same time, this nitrogen, the diazo group will remote in the form of nitrogen, and we will get carbocation. But in case of aryl amine or aromatic amine, the diazonium salt is quite stable. Is shown here. Here aryl diazonium salt is made, but this is very unstable. Why it is so? Because the resultant carbocation, which is the phenyl carbocation, is very highly energetic. It is very highly unstable. So in this reaction, an unstable species is formed. So if an unstable species is formed, this reaction will not occur. But in the former case, compared to this diazonium salt, this carbocation is more stable. But here in this case, the aryl diazonium salt is more stable than the phenyl carbocations. So that's why the aryl diazonium salt is more stable. This diazonium group can be easily replaced. So it's helpful to install some groups which are difficult by other ways. For example, various reactions will be carried out, and how the other group is installed. First, the NH2 group which is present on the benzene ring is first converted into diazo group, and this diazo group can be easily removed, and it can be substituted by other group which is not possible by other ways. For example, the first one is the Sandmeyer reaction. In Sandmeyer reaction, halogen or cyano group is installed over the ring by the use of salt which is called copper salt. How it is done? Here the direct halogenation or chlorination or iodination is not possible, but it is possible, and especially cyano group, introduction of the cyano group is very difficult. So it can be done with the help of diazotization reaction. First, amino group nitration takes place, and then nitration is converted. Nitro group is reduced to NH2, and then NH2 is converted into diazo group, and this diazo group can be easily removed, and the various group can be installed over the ring, which is not possible by other ways or any other direct ways. For example, here bromine is installed over benzene ring in the presence of copper bromide. Similarly, chlorine can be installed by treating this diazonium salt with copper chloride. Similarly, in the case of iodine, and similarly the cyano group is installed over the ring by treating the diazonium salt with copper cyanide. The second one is the Schumann reaction, in which fluoroboric acid is used to convert the diazonium salt into fluorobenzene, as shown here. Here a diazonium salt is treated with the fluoroboric acid. It's not possible by the Sandmeyer reaction, so a special reaction is used for that, and that is called the Schumann reaction. In Schumann reaction, this diazonium salt is replaced by the fluoro group. Other substitutions are also possible. For example, with water, the diazonium salt is replaced with hydroxyl group, as shown here. When the diazonium salt is heated with water, so then this diazonium group is replaced by the OH group. The direct installation of the OH group is not possible, but it make possible by the treatment of the diazonium salt with water by heating. Similarly, if you want to replace this by hydrogen, then the diazonium salt is treated with hypophosphorus acid. This is hypophosphorus acid. When the diazonium salt is treated with phosphorus acid, then the diazonium group is replaced with hydrogen, is shown here. This is a diazonium salt. When it is treated with the phosphorus acid, then this whole group is replaced by hydrogen and we can get benzene again. The fourth reaction is the diazo coupling reaction, in which the N2 group, the diazo group, is not substituted as we have mentioned in the earlier reactions, but it couple with the other group. Maybe the other group, other atom, maybe nitrogen, maybe oxygen, maybe carbon. How it occur? We know that diazonium ion is a resonance stabilized species. This is a diazonium ion. In this diazonium ion is a resonance stabilized species. These electrons are shifted here by shifting of this electron to this nitrogen. Then the positive charge appear on this nitrogen. So this group can act as an electrophile because this is an electron deficient species. Although it is a weak electrophile, so for a weak electrophile to react, we will need a strong nucleophile or strongly activated ring. So it mostly show electrophilic substitution reaction. It means it is electrophile, but the nature of the electrophile is very weak, so it show electrophilic substitution reaction, but with those compounds in which the ring is highly activated. It means where the ring is highly where there is more density of electron is there. For example, like that of aniline. We know that in aniline the benzene ring is bonded with NH2 group. So NH2 group is electron donating group. By donation of this electron, there are electrons with nitrogen, so these electrons are shifted to the ring through resonance effect. So by shifting of these electrons to the ring, here the density of electron is increases, especially at ortho and para position. Same is the case of phenol. In case of phenol, the OH group which is present on the ring is also a electron donating group. These electron in oxygen is shifted to the ring, and by shifting of electron to the ring, the density of electron on the ring is increases, especially at ortho and para position. So this distribution or this giving of electron to the ring make the ring activated. So it's mean it make it more nucleophilic. So if a weak electrophile is there too, it will react with them. Electron with drawing group such as it para are further enhance the activity of diazophenyl carbocation. When especially these are the nucleophilic, but how to enhance the reactivity of these diazonium ions? The diazonium ion reactivity can be increased when there are electron withdrawing group present at para position or at ortho position. For example, this is a diazonium ion. So at the diazonium ion, if some group are present at ortho position, for example, this is ortho position, this is also ortho position, and same is the case if the group are present at para position. So still the reactivity of this diazonium carbocation is enhanced. Is shown here how it is enhanced. When a nitro group, which is an electron withdrawing group, it present at para position, then it increase the electron, it increase the reactivity of this diazophenyl carbocation. How? This draw electron from this. By drawing of electron from this diazo group, it enhance its reactivity. It means it make it more positive. When it become more positive, so its electrophilic nature will be enhanced or increases. How it is increases? By drawing these electrons. When the electrons are shifted here, by shifting of these electrons, then these electrons will be shifted here, and by after shifting of these electrons, the electron will be shifted here, and then these electrons will be shifted here. That is why on this oxygen negative charge is also appear, and a double bond is created here, where in the former case it was single, and in this case the double bond is appear here too. So here more positive charge is produced. So that's why when the ortho position or at para position some electron drawing group are present, then it will enhance its electrophilicity. Diazo coupling reactions with phenoxide or phenol. There are two possibilities of coupling of phenoxide with the diazonium cation. This mostly we have mentioned earlier that it may be the phenol ring. This is OH. This is called phenol. But if hydrogen is remote and there is negative charge on oxygen, then this is called a phenoxide ion. And this phenoxide ion is more reactive than, more nucleophilic nature than the phenol, because here the electron are present in the negative charge, and here electron are present in the lone pair of electron. So here the electron density is more, so its nature of reactivity will be more. So when benzene diazonium cation react with phenoxide ion, so by reaction with phenoxide there are two possibilities for this reaction. Either this diazonium part of the diazonium diazo group of the diazonium cation will couple with oxygen of phenoxide, or it will couple at carbon position at carbon of the aromatic ring. It will couple it. It can couple at ortho position as well as at para position, because here the electron density is more and where the oxygen is at the para directing group. But however, mostly the coupling will occur at para position. The reason is that because at ortho position there is another effect involved which is called steric effect, and due to steric effect mostly this diazo group will try to couple at carbon which is present at para position. So first is how it couple, first the coupling of diazo group with the oxygen. So how it couple with oxygen? By we know that the diazonium salt is a resonance stabilized species. This is a triple bond. When the electron is shifted here, by shifting of electron, this positive charge is finished and the positive charge appear here. So this phenoxide ion where the electron density is more, here the electron density is less, so here it attack on this nitrogen. By attacking of this nitrogen, the coupling of oxygen or phenoxide occur with the diazo group of the diazonium cation. In this type of diazo coupling with oxygen of the phenoxide. The second type of coupling is coupling at carbon atom. How coupling take place at carbon atom? We know that already that the diazonium cation is a resonance stabilized species. Here it is there is a triple bond between the nitrogen, and when electrons are shifted here, this positive charge will be vanished and positive charge will be appear on this nitrogen. As we have mentioned earlier, this pino oxide can be react through oxygen, or pino oxide can react through carbon, but mostly it will react at peroxidation. How this react at peroxidation? Here the electrons are shifted and form a double bond, and then these electrons are shifted here, again double bond will be appear here, and then these electrons, where electron density enhance, here this will shift or it will attack on this diazo group. After the attacking, this species will be formed. After the formation of this species, their aromatic character is lost. In order to retain this aromatic character, this bond is shifted here, and by shifting of this, the aromatic character restored, and this oxygen become negative. So when this oxygen become negative and this hydrogen is removed, so after the removal of hydrogen, then this negative charge on the oxygen will drag or will take this hydrogen and will be converted into OH group. So the coupling at carbon take place, and this coupling take place, this group is called azo group, and this group is very important group, especially it is used in color industries at a very alarming rate. Second, it is also react with aniline. As in the former case with the phenol oxide, aniline can also react at two position with diazonium salt. For example, this is diazonium salt, so aniline can react with diazonium salt at two position. This is aniline. So aniline has two position for reaction with diazonium cation. One is it react with diazonium salt at this nitrogen. Here the positive charge is present, and here the number of electron is more in the form of fluid pair of electrons, so it can react at this position. Or second, these electrons are shifted to the ring, and it increase the electron density at ortho position and as well as at ferro position, but mostly it react at ferro position, not at ortho position due to steric hindrance. So its second, it can react through nitrogen as well as it react through carbon. So there are two type of coupling. There are two possibilities of coupling with aniline. The first one is the coupling at nitrogen atom. You see here nitrogen, which has lone pair of electron, it is a nucleophile in attack on this nitrogen of the diazo group. By attacking at this position, we can get this species, from which then hydrogen is eliminated in the form of positive charge, and we get this compound where in two group of the diazonium salt is coupled with the nitrogen of aniline. The second one is the coupling at the carbon atom, where when in each two group shift electron to the ring, so it activate the ring and it increase the electron density at ortho position as well as at ferro position, but mostly the coupling take place at ferro position. The reason is that because of steric effect. Here it is a resonance stabilized. Here the electron are shifted here, and the positive charge will be shifted here, and after the shifting of positive charge, this aniline will shift electron to the ring. It will change into double bond, and then this bond will be shifted here. It will be changed into double bond, and these electrons then attack on the nitrogen of the diazo group. After attacking, we will get this species, and after getting this species the aromaticity is lost, then aromaticity is restored as such that hydrogen is shifted here. By shifting of hydrogen, the aromaticity is restored and we get the final product. Here the positive charge is vanished by shifting of the electron to the NH2 group and we get an azo compound. So here coupling takes place between what? Between the nitrogen and the carbon of the ring. And here coupling takes place between the nitrogen of the diazo group and the nitrogen of the aniline. So it's mean diazonium salt is a weak electrophile, but if on the other hand the aromatic ring is highly activated, if highly activating group are attached with the ring, so then they can react with them. The reaction is of two types. They will be coupled at the atom, for example at oxygen or nitrogen, or it may couple with the carbon atom which is present in the ring. Application of diazo coupling reaction, especially is a result of diazo coupling reaction, various type of azo dyes are formed. In these azo dyes are used in paints as well as they are used in cosmetics, as well as they are also used for coloring the foodstuffs too. The food coloring especially, they are a little bit dangerous, so that's why they are regulated by the FDA. It is an agency which regulate, which watch the food stuffs in order to make them not poison. It also use compounds which make fruity pebbles, the various colors of sweets which are made, especially these are made by the use of azo dyes compound. These are some azo base dyes which are used. This is a red number 40. It is the common name of this color compound, this dye where azo group is present. Similarly, this is another type of azo-coupled compound which has yellow color and it is yellow number 6. And similarly, this is another type of azo dye which is used for coloring purposes, and that one is called orange number 1. And this is the end of this lecture. Thank you for watching this video. If you have any question about the lecture, if you do not know anything in this lecture, then you can directly contact me through my WhatsApp or you can directly call me. These are the references from which I have taken this lecture, and you can study these books for further study if you want. Thank you again for watching this video.